My name is Kugan. I'm a CPU compiler engineer at NVIDIA, and in this presentation, I'm going to talk about our experience enabling AutoFDO on AArch64 systems. The presentation is going to have some overlap with Honza's AutoFDO presentation on the first day. He went into a lot of details there. So if you haven't seen that presentation, I would highly encourage that you watch that one online when it's available. So the outline for today's talk is like, I'll start off with a brief introduction to AutoFDO for the completeness sake, and then go into ways in which we can collect profiles in our AArch64 system using SPE or BRBE. BRBE is the LBR equivalent in AArch64 to capture the branch checks, which is somewhat of a new thing and may not be available in all the AArch64 processors. It's probably available only on the newer ones.
What is BRB, LBR, SPE?
Okay, sorry, yeah. BRBE is the branch record buffer extension that ARM has. I believe it is, I don't remember the exact version, is 9.1, I think. From 9.1 onwards, it's supported. SPE is the static profile extension. So the BRBE works with PMU, like LBR is, again, the last branch record.
The Intel's x86 last branch record that we have, and BRBE is the equivalent.
Yes. So that's through the PMU interface. And SPE is a completely different interface for different purpose in ARM, which can also be used for AutoFDO. But it requires some additional tweak for us to get working, which I will talk about later. I will also talk about the challenges with profile annotation in AutoFDO, mainly to highlight some of the issues we still have that we have to resolve in the near future. The profile-directed optimization is where we use representative workloads to direct the compile optimizations. The process is to capture the profile with the representative workloads and then feed that one to the compiler such that the compile optimizations are guided through this profile instead of using generic heuristics. The hope here is that we'll have an application that is optimized for real use cases. At least that's the hope here. So there are a couple of ways in which we can actually capture profiles. As you would imagine, like one is the instrumentation-based, the other one is the perf-based, which is what AutoFDO uses. So AutoFDO profile with perf is very low overhead. That makes it easier to deploy in production. That is probably the biggest advantage here. However, the annotation of the optimized, the profile collected with optimized binary is a challenge. And the key here is to doing that one correctly. The low overhead nature of the AutoFDO makes it possible to deploy this one in a continuous deployment pipelines. That's what some of the customers use. Since GCOV is a profile format that actually has basically execution counts for source offsets within the function, this is kind of resilient to some amount of code changes. So the thing is you can, let's say that you profile revision 1 of the application and use that profile to optimize your next release. So the profile collection can be done in the production using the previous version, as long as the changes are not too much, this works well. So again, since we have collected the profile using binary that is optimized, and we are going to use that one to annotate the early IR. So we have to consider the effect of all the code transformation that might have happened in the optimizations. So for example, a lot of inlining would have happened. So the AutoFDO basically creates the inline stack. And also does some amount of inlining based on whether the inlining decision was turned out to be hot even in the profile. And if we didn't inline, we kind of offline that one. And Honza also has implemented an offline pass, which does a lot of clever changes to handle cross-module optimizations and things, cross-module inlining and things like that one. For clone functions, we would end up having multiple profiles for the same function, so that has to be merged back. That we do right now. But code duplication and code deduplication is kind of a challenge that we don't handle right now. So things like ICF, identity code folding, might create one function from two or many, and that gets profiled as one. And we don't currently propagate that one back to the original functions. Similarly, loop unrolling or vectorization, is not handled right now. The other thing is, like, if you have private functions, multiple private functions with the same name, there's going to be multiple profile for those functions, and we don't currently differentiate between them. And there's a patch done by Drew, actually, that also adds the source file name to the profile so that we can kind of differentiate those functions and annotate them. So yeah, these are some of the challenges that we have. So for the current status of AArch64, we can actually do AutoFDO using BRBE and SPE. BRBE works out of the box because it's kind of similar to LBR. So LBR is supported, and the profile gets collected in perf in a similar way, and it can be consumed using AutoFDO tools. But SPE is different. SPE packets are not encoded in a similar way to the PMU representation. So we had to extend the AutoFDO tools to add this support. So there are some local patches we have which we are trying to upstream, which are also available as pull requests. That is needed if you're going to try it out. In GCC side, AutoFDO is target independent. So all the changes actually Honza and others have done also helps us, and it kind of complement our fixes. On top of that one, we also have added some changes to the AArch64 testing in GCC. So bootstrap testing and some regression testing support was added for AArch64, so that's now functional. Yeah. So this graph basically shows the results we got with SPEC 2017 integer benchmarks. I mean, the performance numbers have actually improved quite a bit during the stage one with all the changes that went in. But still, this is not performing like as we would want it to be. So there is roughly about 4% geomean regression we are seeing with compared to the base case of LTO, as opposed to PGO, which has about 2% performance. I think which is quite similar to the numbers Honza showed. And also this result is about 3 weeks old, so there are also some other changes that went in recently that might actually improve it slightly, which I haven't tested. So even though the result has improved, this is not what we would like to be. So there are some changes that probably we would want to make it as part of this stage 1 to make it even better. So there are a couple of things we are doing right now. The one is the source line tracking. And the other thing is, like, in one of our, in a lot of our analysis, like what we are seeing is the inliner is inlining more when it comes to AutoFDO. So the hot-cold annotations probably can be improved, and LLVM has something called the summary generation. So we have a patch to collect those summary information that probably should help us with better hotness annotation and also possibly better inlining. So which we are currently testing. Yeah, hopefully, Drew is actually doing the work, and hopefully he will send out RFC patch soon so that it can be reviewed, and yeah, possibly for the stage 1. The other main issue is that the code duplications, and Honsa talks about using hierarchical file discriminator to handle these things. But Honsa also mentioned that this is not something that's going to happen in the stage 1. It can be a bigger project and might run into the next cycle. So in the meantime, we could actually, LLVM, like, I think, like, the vectorizer and loop unrolling kind of duplication is something that we run into quite often. So in LLVM, we, before they went into the hierarchical file discriminators, they also had a field of discriminator allocated for code duplication. So when we are actually unrolling, maybe we can record that information there and use that to better, and this looks like a small enough change. I don't know. This is something that we want to give it a try. And there's also the other issue that Honsa talked about in his presentation, which is the multiple inline stacks for the single instructions. Yeah, that's also something that would be nice to be included in the stage 1, this stage 1, that probably can improve the performance. Yeah, this is a short presentation, and that's all I had. And if you have any question, we can probably take it up now.
The challenges of AutoFDO approach, that it maps profile data to the line numbers. Is it a challenge compared to GCAF approach, or this is just, or both GCAF and AutoFDO have the same issues that they cannot distinguish between several inline stacks and prefixed versions of functions?
So I think, like, when you say GCOP, you're talking about the PGO, right?
Yes.
Okay. So the PGO is basically, you kind of insert the counters there, and the counters are inserted at the point, and you can get the counters and then kind of propagate it. Like, I'm not an expert on how it works, and maybe Honsa can chime in here. But for the AutoFDO, the problem is, like, we have optimized binary, and we are profiling the optimized binary, and then using that to annotate the early IR, right? So that has gone through a lot of changes. So this is, I'm assuming that this is an AutoFDO issue, and which PGO shouldn't have.
Yeah, so with the PGO, it works in the way that there's a point in the optimization queue when we decide that we want to insert the instrumentation. So we have some set of functions, and every function has a control flow graph. And in the control flow graph, we identify the minimum number of places where we need the counters to determine the number of executions of every edge. and that what we put into the program and optimize it as a sequence. And then, when you do the read of the profile, you expect the program to be exactly the same as at the time you were generating the profile. No, if not, there will be some error, saying that there's a mismatch. And we simply read all the information there. So there's no problem with like renaming symbols or something, because the program is exactly the same when we instrument and when we read. With the AutoFDO, we don't really instrument, so you are having data for optimized program, and we need to somehow retrofit back to the original form. So that's why you need more plumbing here. Yeah, maybe there's two things which I can, Actually, I think the hierarchical discriminators could be implemented in this stage 1.
Oh, right, okay.
It's not so aggressive change, and I think we can get the infrastructure in like next week.
Okay.
Once we have it, we will have chance in stage 3
to go and fix the
parts.
optimizations, okay.
So that can be done incrementally. It doesn't need to be done all at once. So I'm relatively optimistic here. The multiple call site profile that needs a dwarf extension. So the dwarf 6 is being finalized. So
but I talked to Jakub
soon.
Yeah, but I talked to Jakub yesterday, and he said like no, the infrastructure is already there, but it's not. It's disabled for some reasons, right?
I don't know. Yeah, we need to discuss it in detail.
Okay.
If no one has questions, I can ask more. This is partly for Kugan and for Jan as well. Are there known issues with AutoFDO profiling -02 or 03 optimized binaries? So in the graphs that you have, which optimization level is that?
It's the OFAST FLTO.
OFAST, because I think Jan's presentation mentioned that you recommended line should be just with -G without the optimization flags. And okay, because the line numbers at -02 already may have mistakes, so you can actually misprofile there.
So that's, so that's exactly the thing which we need to solve nicely. So in theory, because we are doing a lot of work to preserve debug info, the information should be sort of the same, but it's not, of course, because if you vectorize, your loop is iterating 8 times less than before, and that's the information which we want to represent explicitly in dwarf, and it also should be useful for GBB. So I think there is kind of some interaction. Like you can think of AutoFDO as a test suite for debugging for quality to some respect.
But maybe we should not be, so is there a better way to map locations in the, profiling locations in the optimized binary to the source code? So we are using debug information because it's there, but is there a better mapping than using line numbers?
I can also try to respond. So in LVM you have two implementations. One is using the debug info, and the other is something which is called pseudo probe, which is basically inserting built-in calls, incrementing counters, but it doesn't generate any code. It's only adding some metadata, which is very similar to what we have in debug info. So I sort of believe that we can get the debug info good enough, and we don't need to use pseudo probes. But yeah, that's the alternative approach.
Okay, yeah.